what if I have another example? What if I tell you, you have Mg. If I ask you on the test or a quiz, whatever it is, here it is. You have magnesium. I don't know why this always looks sideways when I try to draw this. So you have magnesium, and you have fluorine. So I say, okay, show me the process of forming the ionic bond, since you have a metal and a non-metal. So you go to your periodic table right here, and you find magnesium. Find how many valence electron it has. Well, it has 2. Here it is. So we go and draw the 2 valence electrons. Here's 1, and there's 2. Okay. Fluorine. Fluorine has 7. It's in the halogens group. Okay. You say, okay, let's look at the periodic table. What needs to happen? Well, fluorine wants to have 8. So it needs to gain an electron to look like neon right here. Now, magnesium is eager, okay, willing to give up an electron because it needs to also look like neon. But look what happens. So magnesium is going to give an electron to fluorine. Very good. So what happens next? Well, magnesium still has, so this fluorine is happy, but the magnesium still possesses 1. Okay, so, well, what is the charge? If it lost 1, here it is, lost 1, it's going to be a positive. And this one becomes a negative. I'm using different colors to show you where it came from, but they're still electrons. So this is a negative. Okay. So you say, I'm done. No, you're not. Why not? Well, magnesium has 1 valence electron now. It used to have 2. But that's not the octet rule. The octet rule says it needs to have 8. So if you go back to your periodic table, magnesium, if it loses 1 electron, now it becomes like sodium. Well, we know what happened with sodium. Sodium ended up also losing what? An electron to become like neon. So therefore, magnesium has to lose 2 electrons, 2 to become like neon. So just keep in mind, this needs to go back, whatever is here needs to go back and look like the noble gas. So if it's sodium, potassium, lithium, they need to lose 1 electron. And that is why this, and I remember what I told you, they have a positive 1 charge. This is the explanation. And if you go to your ion sheet, and I asked you to memorize this anyway, the monatomic, you'll notice that group 2 has positive 2. And this is the reason. It's because they need to lose 2 electrons to become like the noble gas. So magnesium has to lose 2. Well, where is it going to come from? Well, there's another. You'll draw another fluorine atom. Or you could have done them all in one. And now you have Mg plus 2, and you have F minus and F minus there. Yes, I'll put the electrons so you can see them. And that is why that is why the formula, anytime, if you recall, hold on 1 second here. So again, here's the ionic bond. The positive is attracted to the negative, or the negative is attracted to the positive. So that's your ionic bond. And that is why if you go back and you remember naming, when you went and found magnesium, it was Mg plus F, Mg is +2 and F was -1. Remember what we had to do? We had to cross the charges, and that was MgF2. So all of this comes from bonding right here, the ionic bonding. So once again, be able to draw these bonds, determine how many ions you need if one, until again you have the octet until you have 8. What about ionic compounds? So if I have sodium chloride, NaCl, table salt, what is its structure? Because it's a solid. Well, it has what we call a lattice structure, a lattice structure. Lattice means it's a network of oppositely charged ions in a crystalline structure. So it has a crystal structure. And here's the crystal structure. If you look at it, you'll see that all of these are sodium, the blue, and then the green is, or whatever color is that, is minus. The green, yeah, I'm not sure. The sodium here is the smaller sphere right here. If you notice, it has this intricate structure right here, oppositely charged. They are organized this way, and they build up and build up from really the atomic level all the way to the macroscopic, and they give you these kind of shapes. There are multiple shapes of these for these ionic compounds, but that's what we call a lattice structure. So be able to recognize what a lattice structure is. An estimate of the strength of the bonds in an ionic compound can be obtained by measuring the lattice energy of the compound, which is the energy given off when oppositely charged ions in the gas phase come together to form a solid. So that basically, just understand this as a definition. And again, remember what lattice means.